session we are going to see the parametric equations of a parabola, ellipse, circle, hyperbola and rectangular hyperbola. The Cartesian equation is x is equal to 2at and y is equal to at square. Now, let us see how this parametric form can represent a parabola in particular. See, this x and y are two variables. They are connected by an intermediate variable t, and this t is called the parameter. I'll explain with an example why this t is a parameter. So right now we will take x as a function of t and y as a function of t and try to express t in terms of x here and t in terms of y here and try to get a relation connecting x and y, eliminating t. So this is the way for getting the Cartesian equation of a parabola. Now take up this one. From here you can get t as x over 2a, and using y is equal to at square, we can get t square as y over a. Now t is x over 2a, t square is y over a. So clubbing these two, we can write t square as y over a, where for t we will substitute x over 2a. So it becomes x over 2a the whole square is y over a. Or expanding the left hand side, we get x square over 4a square is y over a. So now cancelling an a on either side, so we are left with x square is equal to 4ay. X square is 4ay, and we know this is the equation to a parabola, which is a U-shaped parabola with the y-axis as the axis of symmetry and x-axis as a tangent at the vertex. So now we are going to draw the picture of a parabola for a specific example. Take up the particular example of the parametric equation x is equal to 2t and y is t square. Now, if we convert it to the Cartesian form, we will have t as x over 2 and t square is, as t square is y, we can replace t by x over 2. So x over 2 the whole square will become y, or that would imply x square over 4 is y, or in other words x square is 4y. So this is the Cartesian equation of the parabola. Now we will give different values for t and get the corresponding values for x and y and sketch the graph of this parabola. Now we are going to give different values for t, get the corresponding value for x using the relation x is 2t and get the corresponding value of y using the relation y equals t square. Now t is a parameter in the sense for a particular value of t we will get the x and the y values. Say we will start with t being -3, then -2, -1, -half, 0, half, 1, 2 and 3. So these are the values of t we are going to choose, and we will get the corresponding values for x. See, whatever is the t value, x takes twice that value, so we will take double these values. So x takes the value -6, 2 times -2 is -4, twice -1 is -2, twice -half is -1, twice 0 is 0, twice half is 1, twice 1 is 2, twice 2 is 4, twice 3 is 6. Similarly, now y takes the form t square, so whatever is the t value, we will square that and give that value as y. So minus 3 the whole square is 9, minus 2 square is 4, minus 1 square is 1, minus half square is 1 over 4, 0 square is 0, half square is 1 over 4, 1 square is 1, 2 square is 4, and 3 square is 9. Now, when t takes the value minus 3, keeping t as a constant, we get the corresponding value for x and y. So that way, to get the coordinates of a single point xy, we keep t as a fixed value. Then, to get the next set of coordinates for another point, we change the value of t and take t as minus 2. Then, for the same value of t being minus 2, we calculate x and y. So you may see that when t is fixed, we get the corresponding x and the y values. So they give the coordinate of a single point. Say when t is minus 3, minus 6, 9 is 1 point. Again, when you change t to minus 2, then for the same value of t, x, y take the form minus 4, 4. So for a particular value of t, when you find x and y, t is a constant. In order to get different sets of coordinates for different points, we keep varying the values of t, so that becomes a variable. So that is why the parameter, it partly behaves like a constant and partly as a variable. Now, taking these coordinates as minus 6, 9, minus 4, 4, etc. up to 6, 9, we are going to plot all these points in a two-dimensional plane using the x and the y coordinates. Now, we'll see what type of parabola we get. Plot the points on the graph. Now, the different values of x are from minus 6, minus 4, minus 2, minus 1 up to 6. So, the various values of x, they range between minus 6 and 6, and the y values range between, say, 0 to 9. You may notice the different values of y are 9, 4, 1, 1/4, etc. It goes up to 9. So the minimum value is 0 and the maximum value is 9. And it may be noticed that no value of y is negative, whereas the x assumes the negative and positive values. So this indicates that we can restrict our area of plot to the first and the second quadrant. So we will have the graph only in the first and the second quadrants. So we are going to have the graph with the tailings in the first and the second quadrant alone. So now we can have the bottommost line as the x-axis and the vertical line is the y-axis here. Now we have to plot the points taking into account the different readings for x and y. For the different values of x and y, we are going to plot the points in the two-dimensional plane. This is the horizontal axis, this is the x-axis, and this is the y-axis. Now, when x takes a value minus 6, y is 9. So when x goes minus 6, y is 9. So that point is here. Then, when x is minus 4, y is 4. So minus 4, 4. Then, x minus 2, y is 1. For minus 2, it is 1. And when x takes the value 0, it is 0 in the sense the origin is also one of the points. Then, when x takes the value minus 1, it is 1 and a quarter. It is just a quarter. So minus 1, you will have a quarter here. Right? Then, When x takes the value 1, it is again quarter to the point is here. Then, when x is equal to 2, it is 1. So, x is 2, y is 1, x is 4, y is 4, which means, see, these points are all symmetric. We can notice the symmetry of these points with respect to y-axis. So, we will say y-axis is the axis of symmetry. Then comes, when x is 6, y is 9. X is 6, y is 9. Which means, so maybe notice that these 2 points are symmetric, these 2 points are symmetric, these 2 are symmetric, these 2 are symmetric, and this is the central point. So it is quite obvious that the y-axis is the axis of symmetry. Now we are going to join all these points by a smooth curve. So the curve passes through the different points, and it passes through in particular the origin, and that is the vertex of the parabola. It is joining all these points, and because we have taken the different values of yes as symmetric points about the origin, we get a symmetric shape curve which is the parabola. So now it will extend up to infinity on this side. So now it may be noticed that this is the vertex. See, this is the vertex because no part of the parabola goes beyond the x-axis. So this point 0, 0, that becomes the vertex of the parabola. Then, by looking into the equation of the parabola, we can find out the focus. X square is equal to 4y is the equation to the parabola. Now, if we compare this with the form x square is equal to 4ay, then it takes upon 4 times 1y. See, we may compare this with x square equals 4ay, which means a is equal to 1. Now, in the case of a parabola of x square is equal to 4ay form, the lattice vector will pass through the focus. First of all, we get the focus coordinates. The focus will lie on the y-axis. So if x coordinate is 0, therefore the focus is at the point. X coordinate is 0, y coordinate is 1. So the focus is at the point 0, 1. So we may see it here. The focus is at the point 0, 1. So it is this way. So let us mark the point 0, 1. 0, 1 is the focus. And see, the horizontal line passing through the focus, the horizontal line passing through the focus is the lattice vector. So it may be noticed that, see, this is the horizontal line passing through the focus. Okay, so this is the lattice vector, and these two ends, so if you mark the points as, say, P and Q. Let us mark these points as, say, P and Q. Then PQ is the lattice vector and the coordinates of Q. So if you notice that the coordinates of Q are, see, the x coordinate will be 2 and the y coordinate is 1. So the x coordinate is 2, y coordinate is 1, and on the other side, the other end is P, which lies in the second quadrant. So its x coordinate is -2, while the y coordinate is 1. So it is -2, 1. So these are the endpoints of the lattice vector. Then, so now we've got the fixed point, which is the focus and the ends of the lattice vector. Then the axis of this parabola is nothing but the y-axis. So the equation of y-axis is nothing but x is equal to 0. Right? So, see, so the axis of the parabola. So the axis of the parabola is nothing but the y-axis whose equation is given by x is equal to 0. Then, the tangent at the vertex is nothing but the x-axis itself, and its equation is y is equal to 0. See, when t takes the value 0, it corresponds to the vertex of the parabola. When t takes the value 1, that corresponds to one end of the lattice vector, and when t takes the value -1, the -2, 1 will correspond to the other end of the lattice vector. So thus, in a single graph of the parabola, we have indicated the focus, the vertex, the ends of the lattice vector, and the equation to the axis of symmetry, equation to the tangent at the vertex. Everything is specified.